So at first we will have a discussion about composite of functions or composite function. So when we are talking about composite function, this is how we represent it, f of g or g of f. This is how we represent composite of function. What does it mean? We will be discussing about that. So suppose we are having a function f of x is equals to x square. And let's say we are having one more function, that is z of x is equals to twice x minus 5. Now, if I will ask you to find f of 1, then quickly you will do f of 1. Okay, f of 1 will be 1 square, that is 1. And if I will ask you find f of 2, simply you will do f of 2. F of 2 will be 2 square, that is 4. If I'll ask you find f of 3, same way, you will be finding f of 3, that is 3 square, that is 9. If you have to find f of k, you will be finding f of k will be at the place of x, you will be writing k square. That's it. We cannot calculate it. This will be f of k. If we have to find f of t, it will be f of t will be t square. Now what if I am asking you to find f of gx? So whatever we have done so far, we will be repeating that. F of 1 is 1 square, f of 2 is 2 square, f of 3 is 3 square, f of 4 is 4 square, f of k is k square, f of t is t square, so f of gx is gx square. Yes or no? If I am writing like this, is it making sense to you? So far, in all the, when we have found f of 1, f of 2, f of 3, f of k, we have done this only. We were doing whatever we are supposed to find, we are substituting at the place of x, we are substituting that value. If we have to find f of 1, we are substituting 1 at the place of x. If we have to find f of 2, then we are substituting 2 at the place of x. If we have to find f of gx, then we will be substituting gx at the place of x. Yes or no?
Yes, ma'am.
So now we are also having gx, another function, that is twice x minus 5. So now at the place of gx, now we can write twice x minus 5. That's whole square. And this is called, f of gx. F of, now only I started the discussion by writing one expression like this, that f of g, that is this one and this one is the same thing. Okay, so f of g means f function f, and inside one more function is there, that is gx function. How we find it? The way we find f of 1, f of 2, f of 3, f of k, same way we find f of gx. Okay, so now if we have to find g of f of x, if we have to find g of, let's say we have to find g of f of x, how we will be finding that? We know, just like the previous one, we know gx is 2x minus 5. If we will be finding g of 1, it will be 2 into 1 minus 5. If we have to find g of 2, it will be 2 into 2 minus 5. If we have to find g of k, it will be 2 into k minus 5. At the place of x, every time we are writing the value which is given over here. Now, if we have to find g of f of x, at the place of x, we will be writing f of x. So, 2x minus 5 we were having as a function gx. So, at the place of x, I am going to write f of x. So, 2 of f of x minus 5. Now, so we will be substituting f of x by x square. So here we need to write 2x square minus 5. This is what g of fx, or we also call this f of g as a fog, g of f as a goff function. Okay, so f of gx, this means f and inside function is gx. How we have to find this one? Now only we have discussed this way. G of f, that means goff. How we find it? G of f of x, like this. supposed to find it the way we have done over here. Okay, so now let's take one question where we will be finding g of f of x, f of g of x. A very simple question I am taking. Suppose if the function f, which is defined over R to R, is given by f of x is equals to x square plus 3x plus 1, and g again it's defined on real number R to R is given by gx is equals to 8x minus 3. Let's find g of fx. We have to find fog. We have to also find gof. Okay, how we will be finding that? Let's see it again. The way we have found earlier in the previous example, same way we are going to do it. Please see it carefully. Okay, so f of gx, first we are going to take the first part, that is f of gx fog. This we have to find. That means inside function is gx. F is outside, gx is the inside function. I have not changed anything. This just this round thing which we call of g of x, that I have just removed from here and written our function like this. Now what is the inside function
Ma'am, can you
is
scroll up?
gx. Can I scroll down?
Yes, ma'am.
So here we have to find f of gx. Here gx is what? 8x minus 3. We have to find as 3. The way we are supposed to, the way we can find f of 1, f of 2,
I
f
have
of
to
3, f of
substitute
4, f of
the
5,
values,
same
right?
way we have. Yeah, what?
We have to substitute the values of 8 gx, right, in f of x.
Exactly. We just have to substitute gx over here. We just have to substitute gx over here. We will just be writing gx here at the place of x. I'll be writing gx whole square, be writing gx means, so x square plus 3x plus 1 we are having f of x as a x square plus 3x plus 1. This is what we are having as a f of x. Now we are going to find f of 8x minus 3. That means at the place of x I am going to write 8x minus 3 whole square plus 3 times 8x minus 3 plus 1. Now we will just do the simplification, few cancellation or whatever possible. Just we have to do the simplification over here and we will end up having f of gx. Okay, this is a function we are having. Now what about g of f of x? This also we have to find. This we can write it as a g of f of x. Fx is a inside function. Now already we are having gx as a 8x minus 3. Already we are having gx as 8x minus 3. At the place of x we have to substitute fx over here. Okay, we have to find 8 of what is fx? Fx is this x square plus 3x plus 1. So at the place of fx we are going to write x square plus 3x plus 1 minus 3. Now we just have to apply the distributive property, open the bracket, and then we will be doing the simplification, and that is our function gof function. Is it clear so far to everyone?
Ma'am, are these composite functions?
Yeah, what?
Like, are these composite functions?
Yeah, this
Okay.
composition. composite function we are discussing over here. We have just started the discussion of composite functions. Okay.
Okay.
Next is, okay, let me take one question over here. If f be a greatest integer function and g be an absolute value function, find the value of f of g minus 3 by 2 plus g of f 4 by 3. Now only we have learned how to find g of f of x, f of g of x. Here we are having the same f of g of x. We at the place of x we can see here we are having minus 3 by 2. At the place of x here we can see we are having 4 by 3. So what we will be doing, let's read the question carefully. Here f be a greatest integer function. Previously function f was given, function g was also, it was given, here also it is given but written in the statement form. So fx is a greatest integer function. We can write f of x is equals to greatest integer function, already it is given. Now what about gx? G be an absolute value function. Okay, so gx is an absolute value function. What we have to find, f of g, at the place of x we will be taking minus 3 by 2, then g of f at the place of x we will be taking 4 by 3. So let's find f of gx first. So f of gx will be f inside function is gx. We will be having f inside function gx is, that means modulus of x we have to put over here. Can you see it? So we will be having greatest integer function, and at the place of x we will be writing modulus of x. Are you getting it? Yes or no?
Yes, sir.
Everyone, are you getting it, how we are doing it?
Yes, ma'am.
Let's move ahead. Here modulus of x, okay, we have to find, we must take x value as a minus 3 by 2 which is given over here, because for we have to calculate at minus 3 by 2. So at the place of x I am going to write minus 3 by 2. Okay, so f of g of minus 3 by 2 we are finding over here. So it will be, here we'll be taking minus 3 by 2. Now modulus function, if you know modulus function, it will always generate the output as a positive value. So it will give the output this minus 3 by 2, this negative 3 by 2 will become positive 3 by 2, and greatest integer function is still there. Now please tell me what we will be having once we will take out 3 by 2 from the greatest integer function, this bracket.
1.
It will be 1, right? Everyone, are you getting it?
Yes, ma'am.
Okay, let's move. 3 by 2 will generate, it will generate 1 point something, and greatest integer function always gives the nearest integer value less than or equals to the given value. Okay, now we also have to calculate g of f 4 by 3. Let's do it quickly. So g of f 4 by 3 we have to find. So g of f of x we are supposed to find at first. G, we are having modulus of x, so modulus will be there, and at the place of x we will be writing f of x, that is greatest integer function x. Is it clear so far? Directly I have written it over here. Okay, is it clear?
Yes, sir.
Yes or no? gx we are having this one. At the place of x we are writing f of x, that is this x we are using. This x we are using and we are writing it at the place of x. Okay, let's continue from here. So we have to find it at 4 by 3. So x value we must take 4 by 3. Again, greatest integer function, we will be taking it out from the this bracket. It will become 3. 4 by 3 will be, let me know again what we'll be having. Anyone?
Ma'am, 1.
Again 1. Again 1 we will be having, modulus of 1 will be 1 only. Now we have to find the addition of this two, this one plus this one. That means we will be adding 1 plus 1. That means we will be having 2. Is it clear?
Yes, ma'am.
Let's move ahead. If we are having, if f of x is piecewise function, that is 1 plus x square over here, x plus 1 over here, and 1 plus x square when x is smaller than or equals to 1, and x plus 1 when x is greater than 1, less or equals to 2, and gx is also given over here, that is 1 minus x. Here the range of x is defined, that is minus 2. X is lying in between minus 2 to 1. Yeah. What we have to find? We have to find f of g x. This function we have to find over here. Let's do it. So how we do? Here f of x, as you can see, it's a piecewise function. The function is just in pieces we are having the function. Okay. And gx is just a general normal function. So what we will be doing? F of gx. F of x, this is how we can write f of gx. Okay. Now f of x is piecewise function. So what? Whatever we are doing in the, whatever we have done in the previous question for finding f of gx, here also we will be repeating the same thing. Okay. So even if it's piecewise function, we have to do the same process. So 1 plus x square we are having. So 1 plus, at the place of x we have to do gx. That's a square we have to do. That's what we were doing previously also. In the next one, x plus 1 we are having. So at the place of x, we will be having gx, that plus 1. Now, the range is given over here for x, that is x is smaller than or equals to 1. Now, we don't have x. We have substituted x with gx. So, we have to take this in range also. Okay, x is smaller than or equals to 1. Wherever we have taken x as a gx, there we, here also we must replace x by gx. And for the other part also we must replace x by gx. Okay, so what we will be taking here, gx greater than 1, less or equals to 2. Yeah. Now what is it? What exactly is gx? Gx is 1 minus x. Let's substitute it. Gx is 1 minus x we are having. So here 1 plus 1 minus x, that's a square. 1 minus x plus 1. Here the interval also again we have to define. That is gx is 1 minus x, that is smaller than or equals to 1. Gx is 1 minus x, that lie between 2 to 1. But if we will be taking this interval only, what about this part? Here gx is also having its own restriction. Gx is having its own restriction. When gx is 1 by 1 minus x, then x must lie in between minus 2 to 1. So this restriction also we have to take in consideration. We cannot avoid it. Let's take it. So we are having one more restriction. We must write it over here. That is x greater or equals to minus 2, less or equals to 1. X greater or equals to minus 2, less or equals to 1. X greater or equals to minus 2. We must keep in our mind that x is greater or equals to minus 2 and less or equals to 1. Okay, that's why I'm writing it over here, so that we will not forget about it. Let's move ahead. So we will be having here, 1 plus a minus b whole square, a square minus 2ab plus b square. So 1 plus 1 will be 2. Here only I am writing 2. 1 minus x plus 1, 2 minus x. Okay, here let's define this interval. 1 minus x is smaller or equals to 1. So if we will just transfer this 1 to other side, it will be minus x is smaller or equals to 1 minus 1, that is 0. Now if we will be multiplying negative sign on both sides of this inequality, the sign will reverse. It will be x greater or equals to 0. Is it clear? Can I write x greater or equals to 0 directly over here? And the other interval also we must keep in consideration, that is x is lying in between -2 to 1. Other one also we are having, please let me know, is it getting clear or not? Other one also we are having 1 minus x, that is lying in between 1 to 2. So here 1 is there, so let's subtract 1 from all the parts. So here we will be having 0, here we'll be having minus x, here we'll be having 1. Now we need to multiply minus on all the minus in all the parts. So the sign of inequality we have to reverse. So here we will be having 0 only, but the sign will reverse. X only, but the sign will reverse, and here we will be having minus 1. So can I write it like this? That x is greater or equals to -1 and less than 0. And here the other interval which was given for g, that is -2 x 1. Is it clear so far?
Like we have to solve the inequality.
Yeah.
Okay.
Once we have substituted g of x at the place of x, we have to solve that inequality. Okay. This is what we are having for now. Now, yesterday only we were discussing, whenever we are having two interval, that this must be
Common interval.
followed and this also must be followed. So intersection we will be taking both the inequalities. So let's see here, minus infinity, infinity 0 we are having, and other one is having -2 and 1. Okay, x greater or equals to 0, that means greater or equals to 0, that means this is what the first inequality is talking about. The next one, x is greater or equals to -2. Okay, solid circle, greater or equals to -2 and less or equals to 1. Okay, that means x is lying in this interval, less or equals to solid circle. Now common region, here can you see the common region? Are you able to find the common region over here? Yes or no?
Yes, sir.
So here this total altogether is giving us that x must lie in the interval solid circle, both are having, so 0 to 1. The other one, let's do it quickly. So we will be having minus infinity, infinity. Points are -1, 0, -2, 1. 0, -1, -2, 1 is also there. Okay. The first part is talking about x is greater or equals to -1. X is greater or equals to, equal sign is there. So greater or equals to -1 and less than 0. Okay. Less than 0, so hollow circle. Next one, x greater or equals to -2, x greater or equals to -2, less or equals to 1, x greater or equals to -2 and less or equals to 1. Here equality sign is also there. So the common part, can you see over here? This is just the common part. Okay. So we will be taking this interval over here. Is it getting clear to you? So we will be taking -1 to 0, but see 0 is having open circle, this hollow circle. Can you see? So it's not touching 0. So -1 to 0, like this. We have defined Again, we have defined this interval, and instead of this, this is what the interval we will be having, and this is the function f of g of x we are having now. This is the expression for the given function, which is in piecewise form. Clear? Is it clear?
Yes, sir.
Yes, ma'am.
And we have found the composite function for piecewise function. We were careful with the intervals also. That's it. Rest of the thing we have done like the previous one only. Now domain. Domain of composite. Domain and range of the composite function. Let's say we are having a mapping diagram. Here we are having 1, 2, 3, 4, 5. Here we are having A, B, C, D, E. 1 is going to A, 2 is going to C. Again, 3 is also going to C. 4 is going to E. And 5 is going to D. Again, one more mapping diagram we are having. That is A, B, C, D. And here we are having X, Y, Z, W. Okay. Let's say this one is defining function f of x. This one is defining function g. Okay. Now, if we have to find f of g of x, what we do? We take the we see whatever is there inside g of x, that is a, b, c, and then f of wait. If we will be having g of x as a, right, instead of this one we will be having, if g of f of x, so at the place of f we will be having 1. Instead of taking it like this, let me explain this way only on the basis of the mapping diagram at first. So what I want to say, that 1 is going to a, and then here a is going to y. Can you see? For the function f, 1 is going to a, and for the function g, that a is going to y. Yes or no?
Yes, sir.
We can write, when we are taking the input as a 1, the output after going through f and then g, it is giving us the output as a y. Another one, when we are taking input as a 2, then 2 is going to c and c is going to z. That means 2 at the end is generating z. Okay. After that, if we are having 3, then 3 is going to c again and c is going to z. So 3 is giving z at the end as a output. Here 4 is giving e, and then e is not there in g. So 4 is giving e, but since e is not there as an input in g, this mapping diagram, therefore we are not having anything over here. Okay, let's take the next one. Here 5 is giving us D and D is giving us W. So 5, when we are taking the input, at the end we are having the output as a W. Okay, that's it. So here, if we have to write the domain of this function, then what we have done, we are having the domain. What is domain? The first, these terms are called domain in the set diagram, and we also know domain is the set of all possible x values. So here possible x values are 1, 2, 3, 5, but not 4, because 4 is not generating anything. Are you able to see? Are you able to see? And yes, this is f of g of x only. That's what we have written. Okay. Not f of g of x. I would say we are taking first x as a 1. And that is, yeah, g of f of x we have written over here. Yeah. Can you see? First we are taking the input x as a 1, and that f is generating a function, and then we are looking at g, what g is generating. Yes or no? We are having
Yes,
here
yes,
g
ma'am.
of f of x. This is what g of f of x we are having over here. Are you able to understand?
Yes, ma'am.
Yes. So we are having g of f of x, and that domain is 1, 2, 3, 4 we cannot take. 5 we will be taking. What is the range? Range is, this one we will not be taking. Range is y, z, w. So domains are 1, 2, 3, 5. Domains are 1, 2, 3, 5, and range is y, z, w. Let's see the mapping diagram. Domain is 1, 2, 3, 5. Can you see? Domain is 1, 2, 3, 5. 4 we have not taken because 4 was not generating the output. And the range is y, z, w. Here y, z, w is the range. Now what we are trying to understand from here, we are trying to understand that when we have taken 4, then we were not getting any output. It can happen. Now let me take a proper function and let me explain the same. So if we are having, let's say we are having a function f of x is equals to x plus 2 over x plus 1, and if we are having a function g of x is equals to x minus 2 over x, and if we have to find the domain of, let's say, f of g of x only, if we have to find the domain of this one, then g of x will take all the values. G of x, here g of x function, domain of this function is everything except 0. Yes or no? This function is defined for all the values of x except 0, because 0 must not be in the denominator. That will make the function undefined. Yes or no? So what
Yes.
will be the domain of this one? The domain of this one will be all real number minus 0. So gx, the inside function, when we have to find the domain of f of gx, first we will be thinking about the inside function. What input the inside function will take? The inside function is gx. We know gx will take all the input, all the real number except 0. Okay. What about the outside function f of something? Okay. So f of x, whatever we are having f of x over here, that is x plus 2 over x plus 1. And the domain of f of x is all real number except which number? Let me know. Which
Minus 1.
Zero.
minus 1. So here fx is saying that I am okay with all the number. I can take any real number, but please don't give me minus 1. So fx is okay with all the real number except minus 1. Okay, except minus 1. So when we have to think about the domain of f of gx, the outside function f of this is saying that inside me, whatever number is coming as a real number, it's okay. I can take all the real number plus, but please don't generate minus 1, because that, if you will generate minus 1, that way the function f of x will be undefined. So we are trying to generate any value over here, but except minus 1. So gx is already excluding 0. It is taking all the real number, but not taking 0. Okay, fine. But fx is already giving us, giving gx a condition. Whatever you are generating as a output value, 1, 2, 3, 4, 5, 6, 7, 8, 100, decimal, fraction, irrational, everything is okay. But please don't generate minus 1. So gx will say, okay, let me check which value of x is generating minus 1 as the output. Okay, the function gx is must not be equals to -1. The function gx must not generate -1 because f will not accept that. Now only we have seen that with the help of mapping diagram. That 4 x value was 4, but it was not generating any output over here. Okay, so let's see over here that gx is x minus 2 over x. That must not be equals to -1. We cannot say that x is not -1. Okay, in this gx function, x will not be -1. That we cannot say. All together must not give the output as a -1. That's what we are trying to say. Okay, so let's simplify it just like the equation, or the way we solve the equation, the way we solve the inequality. Same way we will be solving this one. So we will be having x minus 2 must not be equals to minus x. Twice x must not be equals to 2. X must not be equals to 1. You can check it. When x value will be 1 over here, then the result will come out as a -1. Okay, so gx is already excluding 0. Now fx has given the condition. For that condition, gx must exclude 1 also. So what will be the domain of this function f of gx? Domain will be all the real number except this 0 and 1. So domain of f of g of x will all the real number except 0 is excluded by g only and 1 is excluded by g of f of gx because of the condition of because of the function f of x. Are you getting it? Are you getting it?
Yes, ma'am.
This is how we will be defining the domain of composite function, gov, fog. This is how inside function, whatever domain is there, that we have to take in consideration. But the outside functions domain, or what is not acceptable for the outside function, that also we need to take in consideration. Okay, let's see one more question. Okay, in this function only, if I am asking you what will be the domain of g of f of x, please let me know. No? Function you are having, gx you are having, fx you are having. I am asking the domain of g of f of x. Let me know. Quickly, anyone? I need to scroll up. Now only you said okay. Please, if you want to say anything, please unmute yourself and you can tell me. I have not scrolled up. Which portion you need? Madiha, please let me know the domain of this function. Domain. Anyone? If you have understood the concept, you will be able to find it. Function, if you want to see this, these two are the function. G of f of x domain we wanna find. Okay, so when we are saying g of f of x, g of f of x, here fx, the inside function will is already having the domain as a all the real number minus -1. It will say I can take all the real number but not -1. Okay, now the outside function g is saying whatever number you are generating, that is okay, plus, but please don't give me 0, because if you will give 0 as an output, this gx x minus 2 by x will become undefined. So fx must not generate 0. Are you getting it? This fx must not give output as a 0, because z of 0, you see, z of 0 is 0 minus 2 by 0. In
Yes.
denominator, it is coming as a 0. Getting it?
Yes.
Let me know. So which number we need to exclude from all the real number apart from -1? What will be the domain? All the real number minus -1 and what? Are you doing it? Are you doing it?
Zero.
Yeah. -1, -2. Yes. Yes, -1, -2. That is, if we will be having -2 over here, you can find it also. X plus 2 by x plus 1 must not be 0. This will go to other side. You can take it like that here, or just by looking at the function also you can understand this -2 value will make the function 0. So 0 is not acceptable. -2 we need to exclude from here. Domain will be all the real number -1, -2. Yes, perfect. Let's move ahead. Now we are having, if you have understood very well this composite function, then we are having one question from the previous year question paper. A lot of questions are there. From there I have taken one question, that is, let f of x is equals to sine inverse x and g of x is equals to x square minus x minus 2 over 2x square minus x minus 6 if g of 2 is equals to limit x tends to 2 g of x, then the domain of the function f of g will be number 1 -infinity to -2 union 3 by 2 to infinity, 2 -infinity to -2 union -1 to infinity, c or 3 you can say, -infinity to -2 union -4 by 3 to infinity.
Ma'am, behind minus it should be a closed, right? I mean, open interval, right?
Yeah, what?
Behind in the first option, it should be open interval, right? Behind minus infinity.
Yeah, open interval. Infinity and -infinity, everything we take as a open interval. We are not able to touch the infinity. Okay,
Yes, and
yeah.
that it should be.
Yes, yes, yes. It will be -infinity. By mistake, I have written it. And the next one is -infinity to -1 union. Thanks for telling me. Okay, 2 to infinity. So let's see. We are having this function f of x is sine inverse x, g of x is this one. What we have to find? We have to find the domain of what? Domain of fog, f of g of x. Okay, the composite functions domain we have to find. The way we have discussed just now, we will be finding like that. So f of g of x means what? Fx is given as a sine inverse x and gx is given as a x square minus x square minus x minus 2, 2x square minus x minus 6, 2x square minus x minus 6. Now, what we do when we have to find f of g of x? F of g of x. What is the domain of g of x? Okay, let's see. So here, when we will be taking x square minus x minus 2 over 2x square, if we will be factorizing the numerator and denominator, let's see what are we going to get.
Ma'am.
So we will be having x plus x. So in one bracket x minus 2 we will be having plus x, that means x plus 1 we will be having, check it, minus 2x
Ma'am.
plus x. Yeah.
Is the answer option A?
Option A. Let's check it. Is the answer is option A or what? What about the denominator? Please do the splitting of middle term and let me know. Here we are having 2x square minus x minus 6 we are having. Okay, if we will split the middle term 6 2 times, 12, 4 3 times 12. So 4x, and here we'll be having 3x. Minus is there, so minus 4x plus 3x. Oh, I believe we will be taking 2x common, and in bracket we will be getting x minus 2. And here we'll be having 3 or what? If we'll be taking 2x common, we'll
Plus
be
3.
having
Plus 3.
minus 1.
Plus 3. Plus 3.
Okay, plus 3. Yeah, plus 3. Here we can see plus 3 we are having. So this is what we are having as a function g of x when we have done the factorization of the numerator and denominators part. Why this limit x tends to something is given over here? No, limit g of 2 is equals to limit x tends to 2 g of x. Can you see here x equals to 2? X equals to 2 is just making the denominator 0, and also x equals to minus 3 by 2. These two values are making the denominator 0. But we can also see that x minus 2 is getting cancelled out. This is called removable discontinuity. Discontinuity is there at x equals to 2, but that we are able to remove by doing the cancellation. Okay, such a function we are having over here. That's why this limit g of 2 is equals to this one is given. The continuity is defined over here because the discontinuity which we are having, that is removable. Okay, so gx is simply we are having gx as a x plus 1 over twice x plus 3, and at which value this is not defined, at x equals to minus 3 by 2 it is not defined. So gx can take all the real number, this gx can take all the real number minus this negative 3 by 2. What about fx? What about fx? Fx is sine inverse x, and sine inverse x says that
Minus 1 also,
sine
right?
inverse, it will always lie in between.
Minus 1 also, right?
Yeah, what? You are saying minus 1 to 1?
Like, ma'am, x plus 1 is equal to 0 and x is equal to minus 1.
Yeah.
In the numerator, ma'am.
Yeah. X equals to 1, and denominator we are taking this one. If we are saying at which value the function is not defined, then that is only minus 3 by 2. Right?
Okay, ma'am. Okay. Like, if it is
And
0,
if
then
we,
it is defined.
yeah. And if we have to find f of g of x, at first, here sine inverse function we are having. Okay. We know in about inverse function, we know that this input x must lie in between negative 1 to positive 1. That we know. Okay, for sine inverse x, this input 1 must lie in between negative 1 to positive 1 close interval, that we know. Okay, so let's find f of gx and let's take the interval minus 1 to 1 and let's see whether it is solvable or not. So f of gx will be sine inverse of gx is x plus 1 over 2x plus 3. This is here at this point we can say this will be lying in between minus 1 to 1, because the previous function was very simple function. There it was just by observing the function, it was rational function. Just by observing the function we were able to make the conclusion that this point we need to remove, this point we need to remove, and hence we got the domain. But here it is not that simple to just by observation we can say what will be the domain. So this is what we can write at first, the fork function, and then we can say this sine inverse of x plus 1, or this input 1, x plus 1 by 2x plus 3. This will lie, the input 1 will lie in between negative 1 to positive 1. Is it clear so far? Is it clear so far?
Yes, ma'am.
Yes, ma'am.
Let's move ahead. So if we are saying a certain value is lying in between negative 1 to positive 1, and if we will be doing the square of that, yesterday only I have told you that here this denominator 2x plus 3, whether it is a positive or negative, it will generate a positive output, negative output, we are not sure about that. So if we will be multiplying with the inequality, the sign we have to reverse or we don't have to reverse, that we are not sure about. Okay, so what we can do, we can do the squaring of this one. Now if there is any term which is lying in between negative 1 to positive 1, let's say 0.5, and if you will do the square of that, that will still remain less than 1.
Sign will not
Yes
be
or
changed,
no?
right?
Yeah.
Sign will not be changed, like if you are squaring up.
Yeah, squaring, we are squaring, but at the same time we are also thinking like this, that if we are having any value in between -1 to +1, let's say 0 or 0.5, okay, if we will be doing a square of that, that is square, after doing the square also it will be less than 1. Yes or no?
Yes, sir.
So we can take, after doing a square of this, still it will be lesser than 1. Okay. Now let's move ahead. Here we'll be having x plus 1 whole square. Here we'll be having 2x plus 3. 2x plus 3 whole square. Let's solve it. A square plus 2ab plus b. Here we'll be having a square plus 3, 2 times 6, 2 times 12. ab plus b square. Here we'll be having 3x square. Here we'll be having plus 10x. Here we'll be having 9 minus 1, that is 8. Here please give less or equals to 1. This is the expression which will be there on the right hand side, other side will be 0. Okay, because we have taken everything on the right hand side. Now we can do the factorization of this one. 8 3 times 24, 6 4 times 24. So we can break it like 6x 4x. Okay, so 3x will be taking common, it will be x plus 2, and here we'll be taking common 4. Okay, so x plus 2. So we will be having x plus 2, we will be having 3x plus 4. So that is greater or equals to 0. Now yesterday only we have discussed the concept of wavy curve method. I said that it is not related to any topic, but everywhere we will be using it. So let's use it. We are having minus infinity, positive infinity, critical point is -2, critical point is -4/3. Yeah, -4/3, yeah, like that. Now we are having from the very right we will be placing the sign, but we also have to be careful, our x coefficient must be positive, and also we have to see the powers while jumping the critical point. Here we can see the odd power is there, so plus minus plus, this expression must be greater or equals to 0. That means this is the interval we will be having, and this is the interval we will be having. Here we are having greater or equal sign is also there. So this is solid circle, and this is also solid circle. Let's write the interval. We will be having -infinity to -2, union we will be having -4/3 to infinity. Is there any option like that? Option
Yes,
number
sir.
C. Yeah. Is it clear how we are using wavy curve method and everything, and also the concept of finding the domain of the composite function? Is it clear so far?
Yes, sir.
Let's move
Yes,
ahead.
yes, ma'am.
Okay, now we will be saying now we will be having the discussion related to even function and odd function. Yeah, even function or odd function. So we can say a function is an even function when f of minus x is equals to f of x. Okay, and we can say the function is odd function. This is the definition for even function. This is the definition for when f of minus x we will be finding, that will come out as a minus of f of x, and that is called odd function. So the example of this even function can be if we are having x square. Okay, if you will take minus of x square, again you will end up having x square only. So even if you are replacing this x by minus x, your function is same, x square only. That is one of the example of even function. Or we can also say cos of x. If we are having a function gx as a cos of x, then when you will find g of minus x, again it will be cos of x only, because cosine will just absorb the negative, right? So these are few example of even function. What about odd function? So if we are having, let's say, a function h of x is equals to x cube, this is odd function. When we will take h of minus x, it will come out as a minus of x cube. We can write h of minus x is equals to minus hx, and hence this is one of the example of odd function. Okay, let's take few questions related to this concept. So suppose we are having a function f of x is equals to log of x plus under root x square plus 1. Options are whether it is a even function, it's a odd function, neither even neither odd, none of these, just like that. Okay, so let's see whether it's a even function or odd function. So first we will be finding f of minus x, and we will be checking f of minus x is coming out as a fx or minus fx. Let's see. It can also come out as nothing, neither even nor odd. Okay. So at the place of x, I am going to take negative sign. So it will be minus of x here plus, at the place of x, I will be taking negative x square plus 1, like this. So what we will be having, f of minus x is becoming log of minus x. Here we will be having x square plus 1. So we got log of under root x square plus 1 minus x. This is what we ended up getting. What we are having as the original function, log of x plus under root. So we are not able to say whether it is even, whether it is odd. But is it possible to do any arrangement over here? Let's see whether it is possible or not. So if we will be doing the rationalization inside it, the rationalization, here something minus something is there. So we will be doing something plus something. Okay. So what we will be doing, under root x square plus 1 plus x over under root x square plus 1 plus x. So what the numerator will generate, a square minus b square, something like that, right? So a square will be x square plus 1 minus b square will be minus x square. What about the denominator? The denominator will be as it is, x square plus 1 plus x. Okay. Why we did rationalization, now only you will be able to understand. So we are having log of, in numerator we are having just 1, in denominator we are having x square plus 1 plus x. Can we write it as log of x under root x square plus 1 plus x, that's power minus 1? Can we? Log of
Yes, ma'am.
1 by k can be written as k to the power negative 1, yes or no?
Yes, ma'am. Yes.
So we can write it like this, and logarithm is having the property to just pull this negative sign from the power and just take it in the front. So this negative sign will go and jump and will sit over here. We will be having minus 1 will sit over here. We will be having minus log under root x square plus 1 plus x. This is what we were having the original function. See it carefully. Can you see? So we can say we ended up getting minus fx. Once we have substituted x at the place of x, we have taken minus x, we ended up getting minus fx. Is it even function or odd function?
Odd function.
Odd function. Let's move ahead. One more question we are having, which is, let's say f of x is equals to cos x over x by pi plus 1 by 2. One condition where this sign, this one is greatest integer function, it must be written in the question, then only we will assume it as a greatest integer function. Otherwise this is just a bracket for us. Okay, so it is written that this is greatest integer function, and in the question it is also written that x not equals to n pi. I am not writing the full statement uh, because it will take few more minutes. Now we also have to check whether it's a even. The options are, it's a even function, it's a odd function, neither even neither odd, just like that. Okay, Let's see whether it's a even function or odd function or nothing. So we will be just replacing x by minus x. Okay, cos of minus x over here we will be having minus x by pi plus 1 by 2. The numerator one easily we know it will get absorbed. It will be just cos x. The denominator one we will be having minus x by pi. Now we are not sure what to do with this denominator one. It's a greatest integer function. Okay, we know one rule which is related to greatest integer function, that is greatest integer function of x plus greatest integer function of minus x will be having two possibility. One, if we will be writing the integers over here, if we will be taking x value as a 5 here and x value as a minus 5 here, it will just give the same value. The same value will come out and eventually it will make the answer as a 0 when x will be integer. But when x is not integer, what about that? So when x is not integer, it's not, let me write it over. We are writing here x will give two result depending upon the situation. One is 0 when x is integer. One is another value when x is not integer. Let's say here we are taking 1.5 and here we are taking minus 1.5. So greatest integer value of this 1.5 will generate 1 only. Yes or no? Yes or no? And what about this minus 1.5? Will it generate minus 1?
-2.
Minus 2. Minus 2 it will generate, because on the number line we know it will always generate the value which is the smaller than or equals to this value. The nearest integer value it will give as an output which is smaller than minus 1.5 or equals to minus 1.5. Okay, so it is smaller than minus 1.5 will be minus 2. If you will take minus 1, that value is greater than minus 1.5. So please don't take that. It will give the result as a minus 2. And if we will be adding this 2, then can you see it is giving us the answer as a negative 1. So always two cases will arise when we are having the greatest integer function x plus negative x inside the greatest integer function. Either it will be 0 or it will be negative 1. It will be 0 when x is integer. It will be negative 1 when x is not an integer. Okay, we will be using this concept over here. So here we are having minus x by pi. So we know that x plus, okay, one more thing we must note over here, that it's given in the question that x not equals to n pi. Okay, x not equals to n pi. Why it is given like that? Because if we will take this x value as a n pi inside the greatest integer function only, by pi gone and n is what? Integer. Okay, it's written here where n is an integer. So x not equals to n pi means here this x will not generate n. It will not generate, like it is not an integer. Okay, x is not equals to n pi is giving us the idea that okay, here x is not an integer. So whatever is sitting inside the greatest integer function, that bracket, that is not an integer. So we will be taking the second case, that is negative 1 it will generate. So we know x plus negative x will generate negative 1 when it is not integer. Okay, that means we can write the same thing about, we can use the same formula for our question. In our question it is x by pi. In our question it is minus x by pi is equals to negative 1. Okay, we can take the same value in the first bracket, the same value in the second bracket, that will generate negative 1. This one is the rule and this one we are using the rule. Okay, so we can write this minus x by pi as negative 1 minus x by pi, like this one. Let's substitute it. Let's use this one in our function. So I am going to write this minus x by pi as a minus 1 minus, inside the this one I am going to write as a minus 1 minus greatest integer function only x by pi plus 1 by 2. Now can you see this minus 1 plus 1 by 2 is making what? Minus 1 plus 1 by 2, when you will see, it will generate minus 1 by 2. Okay, let's write it over here. So we are getting cos of x. In denominator, we have done the substitution, that is giving us minus of this minus 1 by 2. If we will take the negative sign common from the denominator, we will be having cos x and x by pi greatest integer function plus 1 by 2. What the original function was there? It was cos x, x by pi plus 1 by 2. Here we have got just negative sign outside. So we can say it's a odd function. Is it clear? Let me know, is it clear or not? I will be taking one more
Yes, ma'am.
question related to this concept, then we'll be moving to the inverse function. Please let me know whether it is clear or not. Yes? Is it clear?
Yes, ma'am.
Yes, sir.
Okay, let's move ahead. We are having one previous year question, that is, let I believe it's from 2021. Let f of x is equals to a to the power x, where a is greater than 0, be written as f of x is equals to f1x plus f2x, where f1 is even function, then f1 x plus y plus f1 x minus y equals to option A, 2 times f1 x plus y into f2 x minus y. Option B, 2 times f1 x plus y option into f1 x minus y. Option C, 2 times f1x into f2y, and option D is 2 times f1x into f1y. Let's get back to the question. Fx is given over here. Okay, we can represent fx as a f1x plus f2x, where f1 is a even function, f2 is a odd function. Then we have to find the value of f1 x plus y plus f1 x minus y. Okay, so let's do it. Now, have you learned the concept of symmetric and skew symmetric matrices?
Yes, ma'am, we know.
It is something like that only. No? Here, one time we are getting minus of f of x, another time we are saying it's odd function, then it's even function. When we are substituting x by negative x, it's giving the same value. Then if you have learned the symmetric and skew symmetric function, then can we represent this f1x as a to the power x plus a to the power minus x by 2? Check it. It says it's even function. So we will be replacing x by minus x and still we will be having the same result. Yes or no?
Yes, ma'am.
F2 also we have to take by, we will be taking it by ourselves only. So can we take F2 as a, F2 is odd function. So can we take it like a to the power x minus a to the power minus x by 2? If we will be taking at the place of x, we will be taking minus x. We have to take minus sign common and then it will become odd function. Yes or no?
Yes.
Is it clear so far? And we also need to check whether both the sum of both is giving us fx or not. So check it whether it is giving us fx or not. Yes, it is generating fx, right?
Yes.
Let's take this f1 and f2 and let's do this simplification. F1 x plus y plus f1 x minus y. Here only I am doing it, okay, so that you can see the question over here. So f1 x plus y, a to the power x plus y plus a to the power minus x plus y over 2 plus a to the power, okay, we need to do it separately. It will, I believe it will take more space. So f1 x plus y plus f1 x minus y, that's what we were having, yeah, x minus y. So a to the power x, that means x plus y, plus a to the power minus x, that means a to the power minus of x plus y, plus again a to the power x minus y plus a to the power minus of x minus y over 2. If we will be taking 2 common, let's see what are we having. This a to the power x plus y. Can we write this a to the power x plus y as a to the power x into a to the power y? Can we?
Yes, ma'am.
The another one, we are having a to the power minus x, a to the power minus y. Okay. So we can write it as a to the power minus x into a to the power minus y. For now, I am writing it as it is. Okay. Plus another one, we are having a to the power x into a to the power minus y. And another one, we are having plus a to the power minus x into a to the power positive y. Is it clear so far? We have just applied the law of exponents over here, nothing else. Okay. 1 by 2 I am keeping outside. Let's see what simplification can be done over here. A to the power x, a to the power y, here we are having a to the power y, here we are having. So if we will be taking this two underlined part together and we will be taking a to the power y common, we will be having a to the power x plus a to the power minus x. If we will be taking this two together, again we can see a to the power minus y we can take out common and we will be having a to the power minus x plus a to the power x. We are able to generate the same result in both the bracket. So factorization, this is how we do a to the power x plus a to the power minus x and a to the power y plus a to the power minus y. Okay, 1 by 2 outside already we are having, since everything is in multiplication, that's why just like this I have opened the bracket. Now we will see the options. We have got a to the power x plus a to the power minus x, a to the power y plus a to the power minus y. It looks like f1x, f2y. It looks like that. But 2, still we have to do the arrangement of 2. Okay. So f1x was, our f1x was a to the power x plus a to the power minus x by 2 we were having as the f1x. Okay. I'm not writing it again. So this 2, if we will be taking along with this a to the power x plus a to the power minus x by 2, this all together I am taking so that we can write it as a f1x. Now we need f2y. Okay, so we need to write 2 in the denominator. For that I have to multiply 2 in the front. Okay, a to the power y plus a to the power minus y. This one I can write f2y, and this one, this 2 in the front will be writing. So we are able to generate 2 times f1x, f2y. Can you see? Option C is the correct option. Is it clear?
Yes, ma'am.
Next one, inverse function. The concept of inverse function we will be taking. Let's take it quickly. Okay. Let's say we are having a mapping A, B, C, D, and we are having X, Y, Z, W. A is going to Y, B is going to X, C is going to, let's say, Z, and D is going to W.
Like if it is 1 1 and onto, then only it's an invertible function, right?
Exactly. Exactly. If it is 1 1 and onto, if it is 1 1 and onto, then only we will talk about the inverse function. And then only we will be saying that it is invertible or what. What is inverse function? So when we are having a function f of x, which is defined like this, like input is a, b, c, d, output is x, y, z, just like that. And we will be able to, we must have, this is function f of x. Okay, till now we know a function, what is function, how to define a function. We have done a lot of operations and everything we have done for the function f of x. Now we are going to discuss about inverse function. So we are saying that there is a inverse of x, f inverse x is there, which is not 1 by fx. No, please don't take it like this. It's not 1 by x, f of x. There is a inverse of the function fx. What is the meaning of inverse of fx? For now, whenever we are taking the input a, output is coming as a x. When we are taking input b, output is coming as a y. When we are taking input c, output is coming as a z. And when we are taking input z, the output is coming as a w. The inverse function will do the exact opposite way. The inverse function will give, when we will be taking the input as a x, okay, when we will be taking input x for the inverse function, the output it will generate as a okay. When we will take input as a y, the output it will generate as a b. When we will take input as a z, the output it will generate c. So exactly opposite way it will start doing. That is the meaning of inverse function. We must have such a function where whatever is the output for now, that will be input, and whatever is input, that will become the output. That is the meaning of inverse function. How we generate the inverse function, just see carefully. Every time whenever we have to find the inverse of any function, this is the process we are going to use. Okay, so I am just taking one basic example. After that we will be doing one question from the previous year. So let's say we are having f of x is equals to 2x plus 1. Okay, we have to find inverse of this function. So let's see the process. So f of x, we can write it as a y is equals to 2x plus 1. Now what we will do, we will write this function in terms of like x equals to something. We will isolate x over here. Okay, we will make the subject x over here, because we are going to change input and output everything in between each other. So what we will be doing, this one we will be shifting to other side. It will be y minus 1 is equals to 2x. X will become y minus 1 by 2. This is how we have just changed the function. We have reversed the function. It became x equals to y minus 1 by 2. This is the inverse of that f of x. Okay, this is the inverse of this f of x. But one more step at last we perform, that is x and y. In general, we are used to see, we are so used to seeing the function as this one, that y is equals to something. Okay, always we are having function like this only,
Like
y
this
is
is the
equals to 2.
invertible function.
Yeah, what?
Like this is the inverse of the fx.
Yeah. So always we are so used to looking, just having the function as this one, y is equals to sine inverse x, y is equals to cos x, y is equals to 8x plus 2 by something plus something, rational function, irrational function. So here also we will just exchange the variable. We will just exchange the variable so that it will look good. So this x I am going to write as a y, this y I am going to write as a x. So this is what we are having. F inverse x became x minus 1 by 2. So what we did, a function was given. After that, we have changed the variable. We have isolated x over here. Okay, we got the inverse function. But at one more step we will be doing, we will be replacing x and y, so that the general standard form we can create over here. And if we will be writing f inverse x, Here other side must be having x only. That's why we are writing it in the terms of x. Is it clear? If it is clear, we will be taking one previous year question. Find the inverse of y is equals to 5 to the power log x. Okay, we have to find the inverse of this one. What we do for finding the inverse, we just isolate x, right? We will be isolating x over here, but how? So how we will be doing that? So we will be taking logarithm on both the sides. So it will be log of y is equals to log of 5 to the power log x. This log x will come
Log
in
x into log 5.
Yes. What do you say?
Nothing.
This is what we are having. Here we will be having log 5. Just a moment. No, let me match the question whether we are talking about the same question or not. Yes, y is equals to options are also there. Okay, let's see how to just convert it. Okay, so we will be having this one. What we want to do, we want to isolate x over here. Okay, so what we'll be doing, if we will be writing log x by log y, and here we will be writing 1 by log 5. Log 5 is what? Just a value. Okay, log x by log y, this way we can write. Now we are having change in base rule, which is log a base b is equals to log a base c over log b base c. This is the property of the logarithm where we change the base. Okay, so here what can be done? If we are having x over here, if we are having y over here, can you see? Are you able to understand and apply this formula over here? If we are having x over here, we are having y over here, we can write it as a log of
E.
base y. Can we write? Can we write it like this? Yes or no?
Yes, sir.
We can write. Okay, now logarithm to exponential form. Logarithm to exponential form says that if we are having log a base b is equals to c, then b to the power c is equals to a. Yes or no?
Yes, sir.
So b to the power c, this y to the power 1 by log 5, that is equals to this x. Are you getting it?
Yes, sir.
And this is how we have isolated x. That's what we do when we have to find the inverse. One more step we will be doing and we are done. We just have to replace x with y so that we can say f inverse x is equals to this. We replace this with y. We take this as a x. So it will be x to the power 1 by log 5. Okay. This is how we find the inverse of any function. Okay. Now, let me know whether this one is clear or not. Quickly, let me know.
Log S or Y?
Yeah, what?
Log S or Y? Last.
No, it's not by. We are just replacing x with y.
Okay.
Is it clear? It's not by. This step is just a separate step. Is it clear? Yes or
Yes.
no? So this is how we will be using the formula. And one more question is from the inverse. Let me see.